Welcome to this class. We are talking about integration by partial fractions. That's what we are talking about. And integration by partial fractions. In the last class, I taught you that when you are integrating a function like this one with respect to x, the solution is ln x plus c. You recall? Now we want to see functions that have 1 over value like x, how they are worked out. Very simple example is when we integrate 1 over x minus 1 with respect to x, we will get ln x minus 1. Very simple, plus c, where c is the constant of integration. Where c is the constant of integration. Now, there are cases where we want to integrate. There are cases where we want to integrate functions of x. We want to integrate functions of x that look a little bit different from this, but we must make them look like these two functions here. Example is 11 minus 3x all over x squared plus 2x minus 3. This is a function. So if we want to integrate this kind of function with respect to x, we must convert this particular function to look like this so that we can be able to solve easily as we have solved this one. So the first thing we'll do is we split the denominator by quadratic method. For example, the quadratic method we use here can be the method of quadratic formula. We can use quadratic formula because this one is a quadratic expression. We can use quadratic formula or we can use factors. Let's use factors. So x squared plus 2x minus 3. Product is sum is 2, product is negative 3. So two values, if you multiply, you get this, and if you get that. What are those two? Those two are very easy. You can get negative 3, negative 1, and positive negative 3, positive 1, or positive 3, negative 1. So I think this cannot do, this one will do. So those are the two factors which can give us what we want. So we get x squared plus 3 minus 1 x minus 3. So this gives us x squared plus 3x minus x minus 3. So this gives us x into x plus 3, and then x plus 3. Then we have minus 1. So this gets x minus 1, x plus 3. So these are our linear factors. Linear factors. So as we work this one out, we must use we have gotten linear factors which are giving us the denominator of the above question. So for partial fractions, we can get linear fractions linear factors. 2, we can have it repeated linear factors. We can have quadratic factors, right? So we can have linear factors, we can have repeated factors, we can have quadratic factors, and those are the ones, the divisions of partial fractions. So let's look at the first one, where we are looking at linear factors. Linear factors. The one we have above, as we already saw, just in case you forgot, we have we have 11 minus 3x. We have 11 minus 3x. We have 11 minus 3x, x squared plus 2x minus 3. So this one is approximately equal to 11 minus 3x all over x. We have said it is x minus 1, and it is x plus 3. So we need to split these ones further by partial fractions. So this becomes a over x minus 1 plus b over x plus 3. When we get the values of a and b, then we will have split this expression into partial fractions, which is easier to work with. So now what do? We will write 11 minus 3x divided by x minus 1, x plus 3 on the left hand side and on the right hand side. So on the left hand side and the right hand side, we multiply by the product of this denominator. This becomes x minus 1, x plus 3, 11 minus 3x divided by x minus 1, x plus 3 is approximately equal to x minus 1. So we multiply this one by the same denominator, x plus 3, plus b over x plus 3 multiplied by the same denominator, multiplied by the same denominator, that is x minus 1, x plus 3. And as you can see, the denominator will cancel this one, correct? The denominator here will cancel this one, correct? The denominator here will cancel this one, and this denominator will cancel that one. So what results? This is what is going to result. 11 minus 3x is approximately equal to a multiplied by x plus 3 plus b multiplied by x minus 1. Now, this is what we have. So what remains in this case is, now we get the values of a and b. So how do we get the values of a and b? This is where the gist of this lesson comes. We will write constants. Constants. On the left hand side, the constant is 11, is equal to, on the right hand side, the constant is 3a. Maybe you can open this one to give you ax plus 3a plus bx minus b. So here we are going to have 3a minus b. This gives us equation Roman 1. That's constants. Then we have x values with x. Values with x on the left hand side, we have negative 3 is approximately equal to a, because there is ax here. then plus b, because there is bx here. This gives us from 1, 2. So now we have two values, two equations to solve to get the values of a and b. So now we want to solve our two equations to give the values of a and b. This is simple to solve. What we're going to do is we write 11 is equals to 3a minus b. Then we have negative 3 is equals to a plus b. When we add these two equations, what do we get? When we add these two equations, what do we get? On the left-hand side, you're going to get 8. On the right-hand side, you're going to get 4a plus 0. So in this case now, we can see that 8 is equals to 4a. We divide both sides by 4. So therefore, a is equals to 2. I hope we are together, class. So from there, we get to find the value of b. So from equation 1, we can have 11 is equals to 3a minus b. 11 is equals to 3 multiplied by 2 minus b. Then going to 11 is equals to 6 minus b. This gives us 11 minus 6 is equals to minus b. So we get 5 is equals to minus b. Therefore, b is equals to minus 5. B is equals to minus 5. Now, from there, we are almost done. 11 minus 3x over x minus 1, x plus 3 is approximately equal to value of a. Value of a is 2. 2 divided by x minus 1 minus 5 all over x plus 3. Minus 5 because b is minus. That's why we are writing minus 5. All right. So now when we want to integrate 11 minus 3x all over x minus 1, x plus 3 is with respect to x, it is the same as integrating 2x minus 1 with respect to x minus integrating 5 with respect to x. That's how it's done. From there, we will do what I said we do. So it's going to be 2 natural logarithm of x minus 1 minus 5 natural logarithm x plus 3. That way. So from the loss of logarithms, this is going to be ln x minus 1 squared minus ln x minus x plus 3 raised to 5. This minus here in logarithms can mean divide by. So this can be written as ln x minus 1 squared all over x plus 3 power 5 plus c. So that is how that one is done. That is example 1. In case there is a question, you can ask so that we answer it together. Now we can go to another example. but you can call it example 2. You can call it example 2. You are requested to get I hope you are fine. This is example 2. So we are requested to get the integral of x squared plus 1, x squared minus 3x plus 2. That is what we are looking for. That is what we are looking for. So, with respect to x, so this one, you can split it. You can split this one, the denominator, so that it looks like squared plus 1 all over x squared. Using factors, product is, sum is -3, product is 2. So this is going to be x minus 2x plus 2. That is -1 and -2 in that case. So this gives us x squared plus 1, x into x minus 1, x minus 1. This is positive 2, -2. -2 here. So that gives us x squared plus 1, x minus 1, x minus 2. So this expression must be split using partial fractions. So this expression must be split using partial fractions. So this becomes x squared plus 1 all over x minus 1, x minus 2 is approximately equal to a over x minus 1 plus b over x minus 2. Like that. So you multiply through by the denominator of the left-hand side. This gives you x squared plus 1 is approximately equal to a x minus 1, x minus 1, x minus 2 plus b x minus 2, x minus 1, x minus 2. So this one splits, cancels that one cancels that one. On the left hand side, I've already multiplied, and so it cancelled out. So that gives us a multiplied by x minus 2 plus b multiplied by x minus 1. That is x squared plus 1 on the left hand side. On the left hand side. I hope we are together up to their class. If there is a question, you can ask in the comment section. So from here, already there is a challenge because there are no squares on the right hand side for this case, and so if we continue, then we might not get it right. So we must stop and reconsider the equation or the expression. Stop and reconsider the expression. Now, when you're using partial fractions, you look at the highest power before you begin. If we open this one out, it will give us, as you can see, the original expression. The highest power of x was 2. Here, the highest power of x was 2. So the highest power and the highest power are the same. Since the highest power are the same, then there is something we must do. We must perform division so that we can be able to split this particular expression so that we can solve it when the power of the numerator is less than the power of the denominator, highest power. So we have stopped and we want to reconsider. So this is how we are going to reconsider. That is long division. X squared plus x plus 0x plus power 1 plus 1. We are dividing this one by the denominator, which is x squared minus 3x plus 2. All right. So we are performing division. All right. So we want to begin performing the division. So if you're wondering where I'm getting this, it is x squared plus 1. Here, the power of 2 exists, but there is no power of 1. So I introduced power 1 and I put a 0 there. Then x power 0 exists here. So when you're using long division, it has to come down. It has to move without skipping any of the powers of x in the descending order. So you ask yourself, what will I multiply with this one? What will I multiply with this value of x to get this? Obviously, is 1. So 1 multiplies by this to give me x squared. 1 multiplies with this one to give me minus 3x. 1 multiplies with this one to give me 2. So I perform subtraction. When I subtract, I get negative 1. When I subtract 0 minus 3, I get positive 3x. So those are the values that I get. And so I cannot continue because it stops there. So this is the remainder. So I write my answer as what? I write my answer as x squared plus 1 divided by x squared minus 3x plus 2 is given by 1 plus 3x minus 1 over x squared minus 3x plus 2. That is how you work it out. So you see this is 1. Hii inaingia hapa mara moja, remainder this one. Because after this you cannot continue working. Because there is no other power of 2 remaining. Because here the powers of 2 are cancelled out. So this is what you have. So now it is this part that you're going to split using partial fractions. As previously expressed, we will write 1 plus 3x minus 1 all over x minus 1, x minus 2. Right? So it is this value that we are going to split into partial fractions. So it's going to be 3 minus 1, x minus 1, x minus 2, x minus 1, x minus 2. Yes, x minus 1, x minus 2 is approximately equal to a over x minus 1 plus b over x minus 2. So we multiply through, that is going to be 3x minus 1 is approximately equal to x multiplied by x minus 1, x minus 2 divided by x minus 1 plus b x minus 1, x minus 2 divided by x minus 2. This one cancels, this one cancels, this one. So what you get is 3x minus 1 is approximately equal to ax plus 2 plus b x minus 1, like that. So from here, you look at constants. On the left-hand side, we have negative 1. On the right-hand side, we have minus 2a minus b. This gives us equation Roman 1. Then we go to coefficients of x. Coefficient of x on the left hand side, it is 3. Coefficient on the right hand side, it is a, this one, and plus b. This gives us Roman 2. So now these two equations must be solved. So you write them. Minus 1 is equals to minus 2a minus b. Then 3 is equals to a plus b. Again, we add. So when we add, you get 2 is equals to, when we add this to this, you get negative a plus 0. So this tells you that a is minus 2 from equation 1, negative 1 is equals to minus 2a minus b. So minus 1 is equals to minus 2 minus 2 minus b. So that is minus 1 is equals to positive 4 minus b. You see that? And this one is solved, that you get this goes this side. So you have minus 1 minus 4 is equals to minus b. So this one, you get minus 5 is equals to minus b. Therefore, b is equals to positive 5. B is equals to positive 5. B is equal to positive 5. B is equals to positive 5. Therefore, to finalize on this one, you say that x squared plus 1 divided by x squared minus 3x plus 2 is equals to 1 plus a is minus, let me write a plus b over x minus 2, x minus 1, which is equals to 1. Value of a is minus 2, so that is minus 2, x minus 1. Value of b is 5, so that is 5, x minus 2. X minus 2. X minus 2. So now, when you integrate x squared plus 1, x squared minus 3x plus 2, we get to integrate 1 with respect to x, minus we integrate 2x minus 1 dx, plus we integrate 5x minus 2 with respect to x. So this becomes, when you integrate a constant, you get x. Then minus 2, when you integrate x over 1, you get ln x minus 1. Plus 5, when we integrate, we get x minus 2. Like that. So you can leave it there, or you can continue. It has now become clear. You can leave it there, or you can continue. So this becomes that becomes our answer, that is x. This minus 2 can go up here, so that you have minus ln x minus 1 squared. This 5 can go up here, so that you have ln x minus 2 raised to 5. The minus sign here can make this one a denominator. So it becomes x plus natural log x minus 2 raised to 5 divided by x minus 1 raised to 2. So that becomes our answer. That becomes our answer. So that is enough for linear factors. We go to repeated factors. We go to the second expression we are calling repeated factors. We call it repeated factors. Repeated factors. So repeated factors is where you have 1 over x squared, for example. So 1 over x squared is expressed as a over x plus b over x squared. That is how you have repeated factors. Another repeated factor, you can have 1 over x minus 1 squared. This one is expressing it in partial fractions. It is a divided by x minus 1 plus b divided by x minus 1 squared. In case it was power 3, 1 over x plus 2 cubic, you express it as a x plus 2 plus b x plus 2 squared plus c x plus 2 cubed. So this is how you express partial fractions. This is how you express partial fractions when they have repeated factors. When they have what? When they have repeated factors. This is how you express them, and you get the values of a and b, or you get the values of a, b, and c. Is that okay? All right. So with that, we can continue. Look at example 1. We can look at example 1. Example 1, which says we want to integrate 2x plus 3 divided by x minus 2 squared. X minus 2 squared. X minus 2 squared with respect to x. With respect to what? With respect to x. So how do you do this one? This is how this one is done. This is how this one is done. You say 2x plus 3 over x minus 2 squared can be written as a x minus 2 plus b x minus 2 squared. From there, we say we multiply through by the denominator on the left hand side. So 2x plus 3, that is a x minus 2 multiplied by x minus 2 squared plus b x minus 2 squared multiplied by x minus 2 squared. So this one cancels this one, and this one cancels one of the factors there. So you have 2x plus 3, and we have a x minus 2 plus b. That's what we have. So at this point, we make an equation of constants. Left hand side is 3, right hand side is minus 2a plus b. Coefficients of x on the coefficients of x, we have 2 is equals to, all right, we have a, just a, there is no b. So this is equation Roman 2. This is equation Roman 1. Equation Roman 2. So from equation Roman 2, from equation Roman 2, a is equals to 2. From equation Roman 1, 3 is equals to 2a plus b. So 3 is equals to negative 2 into 2 plus b. So this becomes 3 is equals to minus 4 plus b. So this is 3 plus 4 is equals to b. So therefore, b is equals to 7. From there, we get our partial fractions. 2x plus 3 all over x minus 2 squared is approximately equal to 2 over x minus 2 plus 7 over x minus 2 squared. This is simpler. From this now we can get our answers. From this one we can get our answers. It is very clear, as you can see, that our answers can be found. Well, plus 7 dx, x minus 2 squared. So this one can be done. As you can see, this is with respect to x. So this is 2 ln x minus 2, right? Plus, so you can look at this one. This is going to be 7 ln x minus 2 squared, right? You see that? That should be clear to anyone, as we have been able to see.